Okay, Assalamualaikum and hi everyone. Alright, so we continue our chapter 2.1, okay, part 2 in relationship of light energy and wavelength. So, energy is released when electron drop from higher energy levels to and release radiation energy in the form of photon with specific frequency and wavelength. Okay, so the delta E is given by h times frequency and h is given by c times lambda. This is because c over lambda is equal to frequency. Okay, and then so if different amount energy is released, we can see the light produced is with different wavelength. So the wavelength can be seen as line in the spectrum, and wavelength can be different region in the electromagnetic spectrum. And for example, if the light produced have a wavelength that falls within visible region, it can be seen in various colors. Okay, alright. So ini adalah regarding to the jumlah tenaga yang kita bebaskan. Sebab yang kita boleh faham ialah light terhasil dengan menggunakan wavelength yang berbeza. Jadi wavelength kita boleh lihat di dalam bentuk spektrum, dan juga wavelength juga boleh berada di dalam region ataupun kawasan elektromagnetik, okay, yang berbeza. Jadi contohnya kalau kita ada light yang mempunyai panjang gelombang, it fall between the visible region, so it can be seen in various colors. Okay, kita boleh nampak di dalam pelbagai warna. Okay, so yang saya explain pada awal, kalau you tengok dekat part 1 tadi, okay, ini adalah visible region. Visible region ni maksudnya kita boleh nampak. Jadi yang kita boleh nampak cuma sedikit saja. Dia ada range dia daripada 400 nanometer sehingga 700 nanometer. Okay, dan dia ada ni yang daripada red, okay, sampailah purple. Okay, so ini adalah region-region yang kita nampak lah. Okay, from red to purple. So kita ada merah, okay, orange, okay, red, orange, yellow, okay, green, blue, and then kita ada purple. Okay, alright. So dia mempunyai wavelength, okay, dia mempunyai panjang gelombang yang berbeza. Jadi kalau ke sebelah kiri, okay, semakin pendek wavelength, frekuensi akan semakin tinggi. This is because, okay, frequency is equal to c over lambda. Okay, maksudnya bila frekuensi semakin tinggi, lambda semakin rendah. Okay, kita tengok dekat sini. Sebelah kiri lambda dia rendah, sebelah kanan lambda lebih tinggi. Jadi kalau sebelah kiri frekuensi lebih tinggi, okay, increasing frequency. Alright, so kalau sebelah kanan dia akan increasing wavelength. Okay, alright, the right hand side. Okay, so kita tengok spectrum. So it has a different sorts of light or radiation which produce two types of spectrum. Kita ada continuous spectrum dan juga line spectrum. Jadi apakah dia continuous spectrum? So continuous spectrum dia terhasil bila when a white light is passed through a slit and then passed through a glass prism. Jadi kita lalukan kepada glass prism, so a series of color is seen. Jadi kita boleh nampak cahaya pelangi tu. So white light is combination of various colors. Okay, so sebenarnya white light ni, cahaya putih ni, dia adalah combination di antara semua warna, 7 warna tadi. Okay, right. So different color represent different wavelength. So this spectrum consists of all wavelength. Okay, spektrum ini dia mengandungi semua panjang gelombang bagi visible light dan dipanggil apa? Continuous spectrum. Dan untuk line spectrum pula, when a light form, okay, from a light discharge tube containing a particular element pass through a slit and then pass through a glass prism, a series of light is produced. Okay, bila cahaya daripada kita discharge daripada tube yang mengandungi, okay, elemen yang tertentu ataupun zarah yang tertentu pass through a slit, okay, melalui celahan dan melalui glass prism. Dekat sini kita letak glass prism. Right, a series of line is produced. Okay, satu siri cahaya akan satu siri garisan akan terhasil. So each line correspond to light of a particular wavelength. Maksudnya setiap cahaya ini dia mempunyai particular wavelength. A line spectrum is a series of discrete line with certain wavelength. Jadi line spectrum ni dia merupakan discrete lines with a certain wavelength. Dia mempunyai panjang gelombang. So the series of wavelength produced this way is called atomic emission spectrum. Okay. Alright. So kita tengok nanti kita boleh kira berapakah panjang gelombang dan juga frekuensi tadi. So dia akan relate dengan chapter 2.1 yang kita dah belajar awal tadi ya. Okay. So we have continuous spectrum. Kalau kita tengok continuous spectrum, dia mempunyai all wavelength. Okay. All colors, okay, and then we have sodium, hydrogen, calcium, and mercury. Okay, right. So apa beza di antara continuous spectrum dengan line spectrum? So this is the difference between continuous spectrum and line spectrum. So a continuous spectrum, a spectrum that consists of all wavelength in the visible light. Okay, sorry, in the visible region. And while for line spectrum is a spectrum of radiation that consists of a discrete line with specific wavelength. Okay. Yang kedua, it has no discrete line that separate the colors. Each color merge into next without a break. While untuk line spectrum, it has a discrete lines and each line is separated by a blank area. And then for continuous spectrum, it is a source from sunlight and the light from the incandescent light bulbs. Okay. Dan kalau untuk line spectrum pula, source dia ataupun punca dia daripada light of discharge tube of element such as hydrogen, sodium, and etc. Okay. So formation of line spectrum, pembentukan garisan spektrum. So when an electron of hydrogen atom at its ground state, iaitu n is equal to 1, it absorbs sufficient amount of energy, it will excite to higher energy level. Dia akan diujakan ke aras yang lebih tinggi. So at higher energy level, electron is unstable. Okay, pada aras yang lebih tinggi, electron tidak stable, so dia akan fall back to a lower energy level. So during the transition, semasa peralihan ini, it fall from higher to lower energy level. Energy will be released in the form of light. Okay, at definite wavelength and frequency. So since the energy is quantized, fixed in value, the wavelength can be seen as line in the spectrum. Okay, kita boleh nampak dia yang wavelength yang terhasil tadi dalam bentuk spectrum. Okay, so a series of hydrogen line spectrum. Ini adalah hydrogen line spectrum. Kita ada 5 series. Kita ada 5 series. Jadi siri-siri ini adalah yang pertama sekali Lyman. Okay, siri Lyman, di mana ground state untuk Lyman adalah n is equal to 1. Okay, and then yang kedua B Balmer, n is equal to 2. So any transition that falls to n is equal to 2 is known as Balmer series. And then n is equal to 3 falls to n is equal to 3 Passion, and then 4 bracket, okay, n fall to 4. And anything that falls kepada 5, okay, ground state sama dengan 5 is fun. Fun. So silent P, fun. So we have Lyman, Balmer, Passion, bracket, fun. So this is all the ground state for each series. Okay, ground state untuk setiap siri. Jadi setiap ground state ini, okay, setiap ground state siri-siri ini, dia adalah aras yang paling rendah. Okay, so katalah saya cakap it falls and form bracket series. So maksudnya it form from higher energy level kepada lower energy level sama dengan bracket ground state dia sama dengan 4. Okay. Alright. So macam mana cara kita nak ingat? Kita ada Lyman, Balmer, Passion, bracket, fun. Okay. So you boleh buat mnemonik lah, senang nak ingat kan. Lyman, okay, Balmer, Passion, bracket, fun. Okay, alright. So you boleh ingat Lyman ini ground state dia sama dengan berapa? Sama dengan 1. Bracket Balmer equal to 2 ground state dia. Okay, Passion ground state dia is equal to 3. Bracket ground state dia is equal to 4. Fun ground state dia is equal to 5. So energy level untuk hydrogen atom. So emission spectra ni pula dia sebenarnya dia adalah dia berada dalam region-region yang tertentu. Jadi kalau kita tengok Lyman dia sebenarnya ground state dia sama dengan 1, okey. Jadi spectrum region dia adalah ultraviolet, okey. And then Balmer ni sebenarnya adalah terletak dalam visible region, dan juga passion bracket fund ini semua terletak dalam infrared. Okay, so this one is UV. Okay, so this one is UV. So yang ini apa? Visible. So bracket passion bracket fund semua terletak di dalam infrared. Okay. Alright. So tengok di sini. Okay. And initial dia n must be greater than 1. Kenapa greater than 1? Maksudnya ground state dia mesti lebih besar daripada 1. Jadi dia akan fall pergi n sama dengan 1. Anything yang initial, maksudnya initial dia mesti berada pada excited state. Okay. Right. So kalau macam ni dia akan fall pergi n is equal to 1. Jadi dia akan hasilkan siri apa di sini? N is equal to 1 is Lyman series. Okay. Alright. So kita akan dapat satu line spectrum di sini. So kita buat line spectrum. Okay. So this one 2 fall to n is equal to 1. So it form second line. Okay. Right. This one is third line. This is the fourth line. Okay. So ini adalah Lyman series. Okay. Kalau untuk n is equal to 2 pula. Okay. Ground state dia. So anything that fall pergi 2. Okay. Kalau L tadi Lyman, B is Balmer. Okay. Lyman, Balmer. Okay. So Balmer series first line. Balmer series second line. Balmer series third line. Maksudnya di sekarang ni dia fall pergi berapa? N is equal to 2. So anything that fall to n is equal to 2. Okay. Anything that fall to n is equal to 2 will produce, okay, Balmer series. Balmer series ni terletak di dalam region apa? Visible region. Okay. Alright. So Lyman, Balmer. So this one is Balmer series. Okay. Kalau yang ketiga, sini saya tak tunjuk dalam ni. If it falls daripada 4 pergi 3, 5 pergi 3, 6 pergi 3. So this one dia akan menghasilkan siri apa? Lyman, Balmer, Passion. Okay. Passion series. Okay. Next. Kita tengok pula apa? Di sini kita ada. We have line spectrum of hydrogen atom. Okay, line spectrum of hydrogen atom. Jadi kalau hydrogen atom, okay, so kita boleh tengok di sini di manakah kedudukan siri-siri tersebut. So kita ada di sini, kita ada Lyman, okay, and then Balmer, Passion, bracket, Fun. Okay, so di sebelah kanan, okay, higher frequency, higher energy. Di sebelah kiri, okay, longer wavelength but lower frequency and lower energy. Okay, energy sebelah kiri lebih rendah. Okay, identifying specific line, okay, in the series of hydrogen, iaitu untuk Balmer series. So for Balmer series, okay, anything that falls to n is equal to 2 is Balmer series. Okay, so kita dapat first line, okay, 4 to 2 second line, okay, and then 5 to 2 third line. Okay, kalau this one, okay, kita tengok 3 to 2 first line tadi. Okay, alright, so this is the first line, second line, fourth line. Okay, sorry, third line. Okay, first, second and third line. Jadi kita boleh nampak di sini daripada 3 drop pergi 2. Okay, anything that drop pergi 2 adalah Balmer series. Okay, anything that drop to 2 is Balmer series. Jadi dia sama ni, nampak tak? Kalau dia daripada 5 jatuh pergi 2, yang ini pun 5 jatuh pergi 2. Jadi you boleh nampak dia punya apa tu, spacing between the line dia semakin rapat. Okay, so sampailah di sini, ini apa ni? Infinity. Okay, infinity, sorry, this one is infinity drop to 2. Okay. Alright, so formation of line spectrum in the series of hydrogen atom. Jadi, how do second line of Balmer series is produced? Jadi, Balmer, ground state untuk Balmer tadi ialah apa? Okay, ground state for Balmer is n is equal to 2. Jadi, dia nak second line. Jadi, anything that drop, so 3 jatuh pergi 2, yang ini first line. 4 pergi 2, second line. Okay. Jadi, how do second line of Balmer series is produced? First line, second line. Okay. Alright, so we have third line. Electron at the ground state n is equal to 4. Okay, and n is equal to 1. Absorb energy and excite pergi n is equal to 4. Jadi bila dia n is equal to 4, it is unstable. Thus, it will fall back to n is equal to 2. And then it will release energy in the form of light. Okay. Right. So light energy, wavelength and frequency. So energy released when electron drop is a radiant energy with appropriate frequency and wavelength. So which line produced has the highest energy? Jadi kita tengok highest energy maksudnya, okay, highest energy. Yang mana yang paling longest wavelength? Okay, yang mana lowest frequency? So we have 3 questions here. Okay, so highest energy, line C. Kenapa line C? Because, okay, kita kira delta E is equal to H times C over lambda. Okay, alright. So semakin jauh di sini, okay, energy dia semakin apa? Tinggi. Okay, longest wavelength. So longest wavelength ialah line A. Okay, line A. Longest wavelength. Alright. Has the lowest frequency. Okay, lowest frequency. Jadi frekuensi dia adalah inversely proportional terhadap wavelength. Jadi bila wavelength semakin tinggi, okay, frekuensi semakin rendah. So jawapan dia yang mana? The answer is A. Okay. Alright. Alright, so that's all for our part 2 in chapter 2.1. Alright class, thank you.